All right, so stats and measures of central tendency. As I said, it may be a bit of review. Let's look at the introduction here. So stats involves collecting, organizing, and analyzing data for the purpose of arriving at generalizations and making predictions. In our study of collecting data, we will learn the difference between a population and the sample, and be introduced to various methods of sampling. Data will be organized into tables, bar graphs, histograms, box plots, and ogives. In analyzing data, we will determine measures of central tendency, measures of dispersion, and percentiles. So, funny story, not funny, is the Math 35 students that I'm teaching right now. They, this unit back in 2020 in the spring was after COVID hit. And so it was assigned to them, but no one really did very much. So now they come to this year, they have to write their IB exams, and lo and behold, there's questions on it, and they don't know what. Pretty straightforward. We did review some of it, but we didn't review all of it, and so it does show up on your IB exams. So just because it's fairly straightforward doesn't mean that it's not going to show up. Okay. All right. So population versus sample. Suppose you wanted to predict who would win the next federal election. Ideally, you would like to be able to question every Canadian who's eligible to vote. Okay. That group would be called your population. In statistics, the population is a set of all people or things that should be considered for the whole situation. Okay, what do you want to generalize about? It's too time-consuming and expensive to question every eligible voter. So a more feasible solution is to select a sample of the population that is a representative portion. So collecting that sample and the way that you do that is really important. Okay. So, for instance, a manufacturer of widgets would like to know about the quality of them. So a widget is a word to describe just whatever a factory is making. And so the population would be all of them, and then they would sample it. So often they'll take every 100th item and check. Right? They can't check every one, or they wouldn't be able to produce enough. But they do every 100th to see. Okay, so methods of sampling, there's different kinds, because we can't survey the whole population. So how do we do that? So a simple random sample is every member of the population has an equal chance of being selected, and it's selected individually. For example, every student in your class has their name written on an equal-sized piece of paper, thrown into a box, and 6 names are selected. Okay, so it's random, no order to it at all. So besides simple random sampling, there's what's called systematic sampling. That would be the case of that widget example. Every 100th number, of the population is selected. So maybe every 10th person who passes by a survey, every 20 kids at school alphabetically, something like that. Okay? Now that's a little bit different from stratified random sample. So every member of different segments of the population has an equal chance of being selected. For example, the school is divided into groups by grade. From each grade, a random sample of 10 is chosen. Okay? So you're basically breaking up your population into smaller groups, and from there, random sampling from each of those smaller groups. So maybe it's every period 1 class, we're going to choose 2 people randomly. Okay? So it's called a stratified random sample. That's a little bit different from cluster sample. So a population is divided into groups. Then the whole group is randomly selected, and every member in that group is surveyed. So that would be a case, all of the period 1 classes randomly choose which 5 classes, and then everyone in those 5 classes is asked. Okay? So the groups are randomly selected. That's a cluster sample. Self-selected, that would be if you volunteer, someone volunteers to participate in the survey. So if sometimes you'll hear call in to their radio show or the TV show or whatever. If it's a survey online that you're clicking on that box if you want to answer something, that's self-selected. You have decided. Okay? It's not necessarily a great way because maybe it could be one way or the other. You really agree with that information or whatever the questions are, so you're really interested in answering that. Or maybe you're so mad about this item that they're trying to sell somewhere and it's defective and blah blah blah, so you want to answer it in the other way. So it's not necessarily as good. These are the basic random sample, and all of these ones up to here, are the best. Okay, and then self-selected isn't great. Convenience is where the surveyor is a little lazy and they just go to their friends. Okay, so that might happen. I used to have to, back in the day, there used to be high school dances when I first started teaching, and so the issue was always the music. And so you would send out ask the student council to survey what kind of music, but they would ask their friends. And sometimes with groups of friends, they like the same music. So that's not necessarily going to get you a random and good selection. So that's a convenience, okay, where you poll your friends and family. All right, so those are the types. So now organizing and displaying. So first thing is a frequency table. So you're usually going to have large sets of data and you want to collate them, summarize them a little bit easier. So to better analyze the data, the information, the data is usually organized in a frequency table. The frequency is the number of times a particular value or interval of values occurs. The frequency table can then be represented visually with a bar or column graph for discrete data or histogram for continuous data. So 30 students at Wisewood graph their age. The data is shown below. In the sample, the data consists of only 6 different values. This data is said to be discrete because it takes on only specific values. We're not asking their age in years, months, days, hours, minutes, etc. So it's discrete values. So I want you to fill in that frequency chart based on that data. For E, some people think, oh, this is so easy, but then they lose track. Okay, so what you might want to do is cross them off as you go, and even just do a tally chart. So 17, put a little tally, 14, and then total up the tallies once you're done. That way you don't miss anything. Then I always count up those frequencies and make sure that I get the same as what I started with. So there should be 30, so that's 18, 25, 30. Okay, so a vertical bar graph or column graph can be made from a frequency table. The data values are on the horizontal axis and the frequency of each is on the vertical. The vertical bars of equal width represent the frequency of each data value. So you can complete that once you've got your frequency chart. we've already got the part of it labeled. Here, frequencies, we're going to go up by ones. If you want to go, if your writing is really big, then every 2 dashes, put a label. You always want to label your axes. What do they represent? So this is the frequency. And this would be age. And the title would be Ages of Henry Wisewood Students. Okay, I'm going to try to do a little rectangle here. So for age 16, that's 11. Come on. No, it's going opposite. Okay. Well, interesting. Oh, it ended up being not too bad. Just a little bit higher, I think. Okay, then 7. I'm going to do this. 7 would be down here. I don't want to go wider. Okay, wow. It should be equal width. I'll try to fix that in a sec. And then 7, 4, and 1. Okay, so mine aren't perfect because it's not reading what I'm doing, but try your best to make them equal length. And you can use a straight edge to check across, make sure they go to the correct height. And are pretty close. Okay. If you look to the next page, then we're talking about continuous data. So this would be something like golfer hitting a golf ball. It could be any measurement in between, right? You can have a decimal value. If you're measuring this, the device is accurate, you can go to however many decimal places. So even though we can't measure it in real life that accurately, it's still considered continuous. So what do? You don't want to have one bar for each of these values. That's not going to tell you anything. But you want to split it up into intervals. So recommendation is take the highest and lowest values. Okay, so to basically get what we call the range of values. And then split it up into at least 6 groups, maximum 12 groups. Okay, so when we do this one, the difference is 32.9, and we're going to split it up into 8 intervals. Okay, and that works out nicely, intervals of 5. So notice how these numbers are repeated here. Phones away. Shoot. Seriously. Away. So same values here and here. So what do? Right? Because maybe you have a measurement that's 245. So it says first interval would have a lower boundary of 240, upper boundary of 245, and would include the values greater than or equal to 240, but just less than 245. So here it's really just less than 245, and then greater than 240. Okay? So this one is not going to include 245. This is not going to include 250. If you have those values, you do it in the next one. So that's what happens if you want to split it up like this. Okay? So spend a minute or two, go through and tally up, find the frequency, continue your intervals here. And again, I just cross them off so I make sure I don't miss anything. So 250.0 is going to be in the third row. $265 is going to be in that row. Okay, so those ones, then you check your frequency, total them up here. And then check your total, so 10, 19, 25, 30. Ooh. Then the probability of the ball landing at each of these intervals is just the frequency divided by the total, right? So 1/30th, 3/30th, which is 1/10, 6/30th, which is 1/5, 2/30th, which is 1/15, 7/30th, 6/30th. Okay, and total probability should be 1, right? Because they're all just over, keep it with the same denominator. We always already added those to be 30, so 30 over 30 is 1. Okay. All right, so a histogram can be made using the frequency table of continuous data. A histogram is a vertical bar graph with bars of equal width placed side by side with no space between them. Data values are on the horizontal axis, the frequency of each class is on the vertical. Draw the histogram. Join the midpoints of the tops of the bars to create the frequency polygon, okay? And include a title. So, taking a look here, so we're labeling, this is the beginning of each interval, so 240 to 245. Really, I would put, I call it a little squiggle, all right? It's not starting at 0, so it's like we're squishing that horizontal axis in. It's like it's a piece of wire, okay? And then this would be 250, 255, 260, 265, 270, 275, 280. I don't think we can go up to. Okay, so this is representing the horizontal. This is the length of distance in yards of a golf course. So length. What do you call that in golf? Of a drive, right? I think in golf, yeah. Okay, so those values are the length of a golf drive, and this here we're dealing with frequency. Okay, and this is I don't know if it's one particular golfer, so does it say one golfer? Probably it makes sense that it would be, right? Yeah, a golfer. Okay, so just go through and do your bars. So they are connected. So the next one's 3. I'll try my best with this. Yeah, but here I go up to 3. Oh, I guess I have to do the vertical. Don't mind if it don't. Okay, it's settled pretty good. Close enough. A little bit. Okay, and then the next one is 6 to 7. It might be faster for me to. Okay, I gotta label these 2, 3, 4, 5, 6, 7. So I'm just gonna use lines. It's faster. 2, so we go across there. There. Okay, and then 7 actually. We can go this up to 7. And then and then the next one 1. Okay, so it's 6, 2, 7, 6, 3, 2. 6, 2, 7. Okay, mine's close enough. The smart board is like, that board is lazy. Anyway, should look something like that. Okay. So a histogram is for continuous data like that. Now, the probability distribution, it's a histogram where the vertical axis is the probability. So the only difference here is that your vertical axis is probabilities as a decimal. Take a look at this, 0.05. We have to go up equal units. You can't just switch the scale in between unless there's a squiggly there. So I'm going to put a squiggly here. But here, it's going from 0 to 0.05. So add that, that would be 0.1 would be your next one. Then 0.15, 0.2, 0.25, 0.3, 0.35. Okay? And let's go back because in the probabilities here, I gave them as fractions. So you're going to want to convert them to a decimal to help you out. Okay, so what's 1/30th? 0.03 repeat. I should have told that. Okay. Next one, 0.1, 0.2, 0.06 repeating. 7 divided by 30, I don't know that. 0.23 repeating. 0.2, 0.1, 0.06 repeating. Okay, so then you estimate those bars with those heights. So the first one, 0.03 repeating. You can see it's not at 0.05, it's lower. The next one is 0.1, so that's right on. So here we would go up to 0.01. What do you think the shape of your graph is going to look like? Is it going to look similar or different to the first histogram that we did? It's going to be similar, right? The only thing, it might be squished a little bit depending on that scale of your probabilities, but they're still in the same proportion because you're just converting the frequency to a probability, okay? So I'm going to leave this for you to do because it's going to be pretty much the same. Only thing different here is this is going to be probability. Okay. So shape, they're going to be the same. Now, we're going to look at our TI calculators because actually it can do a histogram for you. Are you going to do that much? Not, probably not, but it is nice to know. One thing I forgot, it asked us back in this histogram to join up the middle points of each bar, and I forgot to do that. So go back to the histogram. So find the middle of each bar, and then I'm going to do it in blue. Join those up with a straight line between each of those. No? Continue there. So that's not what I wanted to do. So here, I'm going to go down. Okay, and then I'm going to do another one here. And then another one here. So you're joining with straight lines. And that's why it's called a frequency polygon. Polygons are made up of straight sides. And so if we were to join this with, say, 0, 0, and the horizontal axis, it would form what we call a polygon. Okay, so just be aware of that. Okay, so now, as I said, we're going to do one in our calculator. So get out your calculator. Now, if you have a Casio, I'm not sure exactly where, so you're going to have to be patient. You can look through for graphs. Okay. Anything with stat, so that you can enter the values. So look for stat in a Casio. It'll be something similar. So here's stat. If we edit on that, we'll see these lists. Basically, a big table of values. I'm going to go up and clear off. So how to do that if you don't have a clear list? You go up and you don't press delete, because that's going to get rid of the whole thing. You press clear and enter, and it'll clear the entire list. Cursor over, up to L1, clear, and enter. Okay, so clear out any numbers that are in there. And then we're going to enter the mid-interval value of each case. So kind of like that frequency polygon. So here, halfway in between 240 and 245. The average, that's 222.5. So 220, not 222, 242. Okay. So halfway, the average of those two values for the median, and then that's going to be 247.5, then 252.5. Basically, you just keep adding 5. That's the width of each interval. So 257.5, 262.5, 265.5. No, sorry, 267.5. 272.5 and 277.5. Okay, so we have 8 entries. Cursor across and put in the frequencies. 1, 3, 6, 2, 7, 6, 3, 2. Okay. Then window, we have to make sure the scale is correct. So go to window and X-min, we're going to go to 235 just to give a little bit of bit of space to the left, to 285, give it space to the right, and those widths of those bars are 5 units, so we'll go a scale of 5. And then just -1 gives that space below the x-axis for y, and maximum 8, because our frequency is 7, our maximum. And then just up by 1s for that. Leave X resolution always as 1s, so don't change anything else there. Okay, and then to graph the histogram, you go to second stat plot, because we are working with some statistics. And then you'll go to, oh, sorry, what did I just do? I did the wrong thing. I did second stat. I want to go second stat plot, which is second y equals. Clear. Okay. Second y equals is stat plot. Okay. First one, or all of them are off. Okay, we're going to turn the first one on. So when you enter on it, Enter on 1 so it's selected, and you'll notice a bunch of graphs. Look for the one that looks like a histogram or a bar graph. Okay? Enter on, select it. Then it'll ask you for your X list, so your data value list is in L1, and your frequency list is in L2. So we have to enter that. So where is L2? It's second key, 2 key. Enter. Mine's graphic a color, so it's just fine. That's just asking what color I wanted. And then press graph. Okay. So then you can cursor through if you want to trace. Oh, actually, I gotta look here. I still had, yeah, it cleared it. I had another function, that's why there's a line going through. There we go, it's gone. If you go trace, it'll go to that midpoint of each top of the bar. And notice how it says in this bar, goes from 240 to less than 245. Okay? And it tells you the frequency. So that's just kind of fun. You know how to do. And then still with our calculator here, well, we will be with our calculator, is what should we review as well, guys? Any questions about calculator? Are you having problems? Okay, so measures of central tendency, mean, median, and mode. Should have learned that back in junior high. That was great. Okay, mean is the average of all the values, so you add them up and divide by however many there are. Median is the middle value when they're arranged in order. Sometimes students forget to arrange them in order. And then mode is the most frequently occurring value. Now your calculator will do all this for you if you put the data in a list. Okay, so there are your definitions. I just kind of briefly went through them. So find 3 measures of central tendency of the following marks on the CUME exam. Let's just go right to doing it with a calculator. Okay, you need to, I'm expecting that you know how to do these by hand. Okay, but let's go how your calculator, when you get to bigger groups of them, it's going to be easier to keep track. So you go to your stats, edit on the list, clear, so go up to L2, clear, enter. Left, up to L1, clear, enter. And enter all those values. Don't put them in order. That's going to take you time. You might as well do it by hand if you're going to put them in order. So enter them as they are listed. Then do a quick scan, like especially on my board calculator, sometimes it doesn't read a value. They're all 2 digits, so that's good. And then if you go to the very last one, oh, sorry. You go to the very last one, it'll tell you which value it is. So that's L1 is at 14, so you want to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Lines there, but 14, so I know I've done that. Okay. Clear out of it. And we're getting our calculator to do this. So we'll stat again, because we're using our stats. And then we wanted to calculate some things. So cursor right to calculate. And what do we want it to calculate? It's called one variable stats. That's the only button we're going to use there for statistics. One variable stats. Enter on that. And you enter where your data is. So your list is in L1. There aren't any frequencies. They're all 1. So if have L2 still in there, probably because of what we did just a minute ago. Change that to 1. They want one value for each of those. Okay? And, oh, what happened there? 2. Frequency list. So maybe can I delete it? Yeah, I think I can delete it. Yeah. So okay, so just delete it. Okay. So our mean is x with a bar over it. Mean is always x with a bar or mu symbol. All right. So in this case, if we go to the nearest, doesn't say what to round to here, but we'll go 2 decimal places. Okay, so mean mark, average mark, median. So cursor down, this arrow means there's more values. There's your median, 79.5. So in this case, the mean and the median are pretty close. And then mode, this one, actually the calculator will give you in this thing. If you did a histogram, you could tell. So this one you are going to have to go through and quickly look to see if there's some repeated values. So there's none there. 96, no. 82, no. 93, no. 95, there's 2. 74, no. 88, no. 77, no. And then 76. So there's 2 modes, 76 and 95. Okay? You don't take the average of them. You just list them. Okay? So that's how your calculator. Other things that it will tell you, we'll talk about standard deviation in the days to come. It tells you the minimum value in your list. It tells you what's called quartile 1, guys. Okay, which we'll learn about. There's your median. It tells you quartile 3, the maximum value in your list. Okay, and then what's nice is it does calculate the standard deviation when we talk about that. Okay. All right, so what happens if we have a frequency chart? So doing this by hand, okay, so here by hand, remember what this means. Students get this mixed up, okay? So here's your data value. Here's how many times it occurs. So this chart is a fast way of writing out these data values. Okay? You don't want to write them out or enter them into your calculator like that. This means there's 4 14ths. So if we were asked to find the mean, we would want to find the total of all of these. So basically here, fx means you're multiplying the value of x times the frequency. So 14 times 4, what's that for? 56. 15 times 5 is 75. 16 times 8, 128. 17 times 6, 60 and 42, 102. 18 times 2 is 36. Okay? Then find the total of all of those 2 columns. So 8, 16, 25. And the total of that, 56 plus 75 plus 128 plus 102. This is my 50, so I'll put in 56. 2 plus 36. And then divide by 25. Okay. Okay, check my answer, because I missed something in my calculator. So, if you got something different, let me know. What's the question, Julie? Did you get something different? Let me know. Okay, so V is mu or x with a bar over top. Okay, in our calculator, this is what we're going to do. So edit here, we have to go up, clear our calculator. We have to put the data values into L1. Got to know how to do this, guaranteed you'll be asked. And you don't want to have to do it the long way. Oh. Okay, make sure they match up. If you don't have values in both columns, matched up, it'll give you an error. So 4, 5, 8, 6, 2. So now, when we calculate the mean, we go to stats. We're going to calculate one variable stats. But now your data values are in L1 and your frequency list is in L2. So L2 is blue 2. Shift or second 2. Okay, there's your mean, 15.88. So it will do it for you. What do you do if you have intervals of values? We gave you a hint, mid-value. So average of those two would be 54.5, 64.5, 74.5, 84.5, 94.5. We don't know the exact values, data values that are in that interval. So we have to average them, okay? And then frequency, so let's not use, do this by hand, let's use our calculator. So stat, edit. Okay, I'm going to clear off my lists. Enter, notice how you can't enter an interval, so we have to enter that mid-value. Okay, then your frequencies. Okay, then stats, calc, one variable stats. We already have L1 and L2. Calculate that. And so we get 73.33. Oh, sorry, 75. Okay, if you look at the data, the most frequently occurring is here. There's 8 in that interval, and this is in that interval as well. Kind of makes sense. Okay, so it makes sense that it's in there. Notice what the median will give you. It's not going to give you anything other than one of the middle values, right? But it's going to be, obviously, because there's 9 here, 7, it's going to be in here. It's going to give you that mid-value of that interval, okay? So that's just going through it on our calculator here. That's the sigma notation, now that we've learned that. And then the last one here, question 3, says determine x if that data and x have a mean of 12. So now you know the answer, right? So the mean of 12, it has to be the sum of all the data values divided by however many there are. 1, 2, 3, 4, 5, 6, 7, 8. Okay, including the x. All right, so really what you want to do, there's 8 data values times 12. That's going to be 96 equals x plus whatever those data values that are given are. So 5 plus 9 plus 11 plus 12 plus 13 plus 14 plus 17. Right, is 81. So x equals 15. Okay. And then just last comments here. The mean is an accurate measure of central tendency if the distribution is symmetrical or approximately symmetrical. Okay. If it's not, so if there's a bunch of really high numbers and then a few lower, or vice versa, then it will drag the mean towards them, right? Because it'll be more concentrated. So it is called, the mean is called a non-resistant measure of central tendency. The median is the only measure of central tendency that will locate the true center, regardless of the data set's features. It is unaffected by the presence of extreme values. Okay, so it's called a resistant measure of central tendency. Just so you know that. A median is actually, like when we talk about averages of marks, a median is probably a better way of looking at it because then you know that it's not skewing one way or the other, but we do always take averages because of that. Okay, so practice is there. There's not much time left, but practice is there. You can start on, and then exercises, measures of central tendency are where now.